Okay, so remember when calculating um, a, a molecular formula, you've got to either have a way to derive the empirical formula and you need to be given a mass. So in this case, we have both. These, of course, should be subscripts, but the formatting got a little messed up. And how you figure this out is eventually you're going to start by solving for x, because x is going to be a multiplier. The empirical formula is, if this is 1, then the empirical formula equals the molecular formula. If it's 2, then the molecular formula is double, et cetera, et cetera. So we know the molecular mass is given to us right here. So what we got to do is we've got to calculate the empirical mass. So we've got 2 phosphorus. So the weight of the phosphorus is, each one is just about 31.0. There's 2 of them. So the mass of the phosphorus is 62.0 grams. And the oxygen, since there's 5 of them, we got 16.00 times 5 equals 80 grams. When you add these together, you end up getting 142.0 grams. Okay, so now we're ready to plug back in. We've got 283.89 grams per mole, and we have 142.0 grams per mole. Basically, these grams per mole or grams cancel, and this right here is functionally 284. So what you get is pretty darn close to 2. All right, so x is 2. So keep that in mind because we're going to plug it in right here. And really, so I'm going to take this, and I'm going to plug in a 2 right here. And we already had the empirical formula. The empirical formula was P2O5. So when you multiply through, you end up getting the molecular formula. And that ends up being P4O10. And that right there is your molecular formula. And the reason why that makes sense is because if you are given this value and you calculate that the weight of this is half of that, that means that the molecule must be double the size of this. So by doubling it, you get the molecular formula. And that's it.